Good morning, Year 8. This is a video just to review the physical and chemical change content that you need to know as an introduction to this topic. Okay, so you have covered and recorded the physical properties that you can see listed on this slide. And I hope that you have defined the ones that you're not absolutely clear on or you can't write a full definition on, because you need to be able to do that. So you need to be able to actually define in writing things like solubility, viscosity. What does melting point and boiling point actually mean? You've also got a list of things that I expect that you already know coming into this topic in Year 8. And then fundamentally, you need to know what it means by a physical change. So when we say a physical change, what we're talking about is a change in a substance. So perhaps a change of state, melting, turning from a solid to a liquid or a liquid to a gas, a change in shape, a change in size, but no change at the molecular level. So remembering when we did elements, compounds and mixtures, some substances are compounds and they contain multiple different types of atoms bonded together. And water is a good example of that. If water undergoes a physical change, those water molecules stay exactly the same. It's just that the space between the molecules, the energy within those molecules is different, but the molecules themselves are the same. They have not changed. You haven't lost any atoms or gained any atoms within those molecules. Okay, so physical changes retains the molecular level of that substance. Some examples are things like, and I think these are on the next slide. Here we go. Changing shape like crushing a can, melting things, so changing state in these two examples, melting an ice cube, evaporating water, turning it into a gas, creating a mixture or dissolving something. All of these things at a molecular level, the substance is the same. It just can look quite different. Again, a mixture, sublimation of dry ice. So when you turn dry ice, so carbon dioxide is a solid, it sublimates, so becomes a gas. It doesn't actually go through the liquid state, but again, that's a physical change because you still have the same structure at the molecular level. So what we are going to go on to today is, and this is just a revision of what physical changes are, chemical change. So you need to know the difference between a physical and a chemical change, what chemical properties are, and some chemical reactions. So we'll have, by the end of this topic, you'll be able to give some examples of chemical reactions that you will be observing in your everyday life or maybe even happening in your body. So when we're looking at chemical properties, there's actually a really good video clip here and I'll post that for you so that you can click on it. We're talking about toxicity, whether it's corrosive or caustic, and we'll get to breaking down those terms into more detail as we go through the course. But acids tend to be corrosive, so when we're handling acids in the laboratory we need to be very careful, and bases tend to be caustic, so again it has similar effects on you, so we still need to be very cautious and wear protective equipment when we're handling bases, but we don't use the word corrosive when we're talking about a strong base. A chemical property could be how reactive something is, so a molecule is or an atom is, and we looked at that when we did the periodic table, so it's really useful for you to have the periodic table at hand when you're doing this part of the course, because we looked at, say for example, the group 1 atoms, and then we described those as highly reactive atoms. So its reactivity is a chemical property, not a physical property. Things like flammable are very familiar to you. Radioactivity will hopefully be familiar to you, and we'll go into that in a little bit more detail later. Again, whether an atom or a molecule is an oxidizer, its pH or its tendency to be explosive are all chemical properties, and they're covered in this video clip here. So I'd like you to watch that just to gain a good understanding of some of those new terms. Fundamentally, you need to know that when a chemical change occurs, we have a rearrangement of the atoms within that chemical reaction. So we don't add any new atoms. No atoms are lost in the chemical reaction. They're all accounted for, but there's a rearrangement. So one molecule, the bonds can be broken within a molecule, and atoms can move and form a new molecule. And that's when we know that a chemical reaction has occurred. Now, there are some ways to observe that, and we'll go on to that in a moment. And you can see evidence of chemical reactions in the home and in your daily life. And that's one of the tasks that I'll ask you to conduct today. Other things about chemical reactions is that, yes, we make new substances that didn't exist initially. So we start a chemical reaction with our reactants, and we end up with products that are different to the original reactants. Chemical reactions tend to be harder to reverse. So a physical change can be easily reversible. There are exceptions, and there are some that are very difficult to reverse. But if you crunch a piece of paper, you can open it out again. If you melt some ice, you can freeze it again. So typically, physical changes that we talk about in Year 8 can be reversed, whereas chemical changes are much harder to reverse and often can't be reversed at all. So these are some examples of chemical changes that you may have noticed around you. Cooking, it's very difficult to uncook an egg because we've caused a chemical change in the molecules in that egg. Rusting, the sticking of glue, once you expose the glue to air or oxygen, that turns into a new substance and it actually holds things together. Burning, maybe combining different metals, producing alloys or producing new metals, and life itself is a very complex combination of chemical reactions that we'll go into more detail on. So very important that you learn a few examples of how we might observe a chemical reaction or a chemical change. Evidence that there's a chemical change occurring are listed on this slide here. So have you seen a permanent color change? Okay, so perhaps hair dye causes a permanent change in someone's hair color and is really difficult to turn back. Bleach might have that effect on your clothes. There are lots of chemical reactions that we will do in the laboratory that result in a change in the color. And indicators, pH indicators, can be a very useful chemistry indicator of a change. Is a gas being given off? So is it starting to fizz and you're seeing bubbles or a foam appearing? That is another example, a very good example of a chemical change. You might observe the gas being given off as bubbles or foam. You might be able to smell the gas. So, and remembering that safety in the laboratory means that you don't sniff anything, you just waft like this so that you're not actually inhaling anything dangerous. So you're just detecting a few of those molecules, but not inhaling too many. Some chemical changes result in light being emitted. So fireworks would be an excellent example. And the color of that light might depend on the molecules involved or the reactants and the products involved in that chemical reaction. And sometimes you'll see the formation of what we call a precipitate. So you might start with a solution and the final products of that reaction may be a solid. And you can see those solids appearing as what we call a precipitate, and that usually sinks to the bottom of the test tube. And we do a little bit of that, we'll do quite a lot of that in Year 10, and we'll introduce those ideas this year. So here we have some that I would like you to list in your notebook. Evidence that a chemical change has occurred is formation of gas, formation of a solid or a precipitate, a change in the color of the reaction or the solution that you're doing the chemical reaction with, production of light or heat. So we did one last term where you held the test tube and you felt that it was actually getting warmer. It was releasing energy into the environment and you could detect that heat change. Sometimes you may detect an increase in mass or a decrease in mass of your original reactants. And that's because a new product has potentially been produced and being lost into the environment as a gas, or potentially something from the environment is being added into your reactants and increasing the mass. So remembering that these atoms aren't created, they're not coming from nowhere, they're being taken from somewhere. On this slide, you've got some examples of chemical reactions in daily life, and that's a really good place to start with today's activity. And here we have just a little bit more on the chemistry of what's happening. Now, two terms I really want to introduce to you. It's very important that you learn to write chemical reactions correctly. So we always have the reactants on the left, the products on the right, and the chemical reaction is represented by an arrow in the center. So you can see here we have reactants on the left and the products on the right, the arrow in the center, and we've got a rearrangement of the atoms, so we haven't added any new atoms. All the atoms are represented on both sides of this equation, but they have been rearranged. So we start with some reactants here, and our products on the right hand side are different. They're new products, they're new substances being created from the reactants that we started with. So they're two really important terms. If I were you, I'd write this down into your book and label these as reactants and these as products. Now, you don't get any new products when we're changing the state of something or when there's a physical change, but you do get new products appearing when there is a chemical change. So you can see that's happened here. Please make some notes in your book and move on to the activities that I've shared with you in Teams.